Removing the main breaker from the outside panel and installing lugs in its place would indeed eliminate the grouping issue. This is because lugs are not considered overcurrent protective devices. Overcurrent protective devices are components like circuit breakers and fuses that are designed to interrupt the flow of electricity when it exceeds a safe level, thereby preventing damage to equipment and reducing the risk of electrical fires. Since lugs simply provide a connection point for wires and do not have any overcurrent protection functionality, they do not need to be grouped together in the same way that circuit breakers or fuses do. Regarding the legality of this modification, it largely depends on the local electrical codes and regulations in place. In many jurisdictions, it is not permissible to remove the main breaker from an outside panel. The main breaker typically serves as the primary overcurrent protective device for the entire electrical system or a significant portion of it. Its purpose is to protect the downstream circuits and equipment from overloads and short circuits. By removing the main breaker, the overall safety and protection of the electrical system could be compromised. If you need to add overcurrent protection to an outside panel without creating a grouping issue, one alternative solution is to install a separately mounted main breaker in a subpanel. This approach involves installing a separate enclosure, known as a subpanel, that contains its own main breaker. The subpanel is then fed from the main panel, and the main breaker in the subpanel provides overcurrent protection for the circuits connected to it. This method is generally considered safer and more code compliant because it maintains the required overcurrent protection while also allowing for the addition of new circuits without causing a grouping issue in the main panel. When dealing with electrical modifications and installations, it is crucial to consult with a qualified and licensed electrician who is familiar with the local electrical codes and regulations. They can assess the specific situation, provide guidance on the best course of action, and ensure that all work is performed safely and in compliance with the applicable codes. Electrical work can be dangerous, and it is always best to err on the side of caution and seek professional assistance. Consider the main panel as the central distribution point for electrical power in a building. It receives power from the utility company and distributes it to various branch circuits throughout the building. The main breaker in the panel serves as the primary disconnect and overcurrent protection device for the entire electrical system. It is sized to protect the panel and the downstream circuits from overloads and short circuits. Subpanels are additional distribution panels that are fed from the main panel. They are used to provide additional circuit capacity and to isolate circuits for specific areas or purposes. Subpanels typically have their own main breaker that provides overcurrent protection for the circuits connected to them. The National Electrical Code, or NEC, is a widely adopted standard for electrical installations in the United States. It provides guidelines for the safe and proper installation of electrical systems. Local jurisdictions may adopt the NEC as is or modify it to suit their specific needs. It is important to be familiar with the applicable electrical codes in your area before performing any electrical work. Overcurrent protection is the process of protecting electrical circuits and equipment from excessive current flow. Overcurrent can be caused by overloads, short circuits, or ground faults. Overcurrent protective devices, such as circuit breakers and fuses, are designed to interrupt the flow of electricity when it exceeds a safe level. Circuit breakers are electromechanical devices that automatically interrupt the flow of current when an overload or short circuit occurs. They can be reset after the fault has been cleared. Fuses are overcurrent protective devices that contain a fusible link that melts and breaks the circuit when an overcurrent occurs. Fuses must be replaced after they have blown. Grounding is the process of connecting electrical equipment to the earth. Grounding provides a low impedance path for fault current to flow back to the source, which helps to protect people from electric shock and reduces the risk of electrical fires. Bonding is the process of connecting different metal parts of an electrical system together. Bonding ensures that all metal parts are at the same electrical potential, which reduces the risk of electric shock. Wire gauge is a measure of the diameter of a wire. The larger the wire gauge number, the smaller the wire diameter. The appropriate wire gauge for a particular circuit depends on the amount of current that the circuit will carry. Conductors are materials that allow electricity to flow through them easily. Copper and aluminum are common conductors used in electrical wiring. Insulators are materials that do not allow electricity to flow through them easily. Insulators are used to cover wires and other electrical components to prevent electric shock. Electrical boxes are enclosures used to protect electrical connections and devices. Electrical boxes are typically made of metal or plastic. Conduit is a tube or channel used to protect electrical wiring. Conduit can be made of metal or plastic. Electrical tape is an adhesive tape used to insulate electrical connections. Electrical tape is typically made of vinyl or rubber. Wire connectors are devices used to connect two or more wires together. Wire connectors are typically made of metal or plastic. Voltage is a measure of the electrical potential difference between 2 points. Voltage is measured in volts. Current is a measure of the rate of flow of electrical charge. Current is measured in amps. Resistance is a measure of the opposition to the flow of electrical current. Resistance is measured in ohms. Power is the rate at which electrical energy is transferred. Power is measured in watts. Ohm's law is a fundamental law of electrical circuits that relates voltage, current, and resistance. Ohm's law states that voltage equals current times resistance. Watt's law is a fundamental law of electrical circuits that relates power, voltage, and current. Watt's law states that power equals voltage times current. Electrical safety is of paramount importance when working with electricity. Always take precautions to protect yourself from electric shock and other electrical hazards. Always turn off the power before working on any electrical equipment. Use insulated tools and equipment. Wear appropriate personal protective equipment such as safety glasses and gloves. Never work on electrical equipment in wet or damp conditions. If you are not comfortable working with electricity, hire a qualified electrician. The National Electrical Code, or NEC, is a comprehensive set of standards for electrical installations. It is updated every 3 years to reflect changes in technology and best practices. The NEC covers a wide range of topics, including wiring methods, overcurrent protection, grounding, and bonding. It is essential for electricians and other electrical professionals to be familiar with the NEC. Article 100 of the NEC contains definitions of terms used throughout the code. Article 110 covers general requirements for electrical installations. Article 200 covers the use and identification of grounded conductors. Article 210 covers branch circuits. Article 215 covers feeders. Article 220 covers branch circuit, feeder, and service calculations. Article 225 covers outside branch circuits and feeders. Article 230 covers services. Article 240 covers overcurrent protection. Article 250 covers grounding and bonding. Article 300 covers wiring methods. Article 310 covers conductors for general wiring. Article 314 covers outlet, device, pull, and junction boxes, conduit bodies, fittings, and handhole enclosures. Article 320 covers armored cable type AC. Article 330 covers metal-clad cable type MC. Article 334 covers non-metallic sheet cable types NM, NMC, and NMS. Article 338 covers service entrance cable types SC in use. Article 340 covers underground feeder and branch circuit cable type UF. Article 350 covers flexible metal conduit type FMC. Article 352 covers rigid polyvinyl chloride conduit type PVC. Article 356 covers liquid type flexible non-metallic conduit type LFNC. Article 358 covers electrical metallic tubing type EMT. Article 362 covers electrical non-metallic tubing type ENT. Article 366 covers auxiliary gutters. Article 368 covers busways. Article 370 covers cable trays. Article 376 covers metal wireways. Article 380 covers switches. Article 382 covers non-metallic extensions. Article 384 covers switchboards and panel boards. Article 390 covers underfloor raceways. Article 392 covers cableways. Article 393 covers low-voltage suspended ceiling power distribution systems. Article 394 covers concealed knob and tube wiring. Article 396 covers messenger-supported wiring. Article 398 covers open wiring on insulators. Article 399 covers outdoor lighting equipment. Article 400 covers flexible cords and cables. Article 402 covers fixture wires. Article 404 covers switches. Article 406 covers receptacles, cord connectors, and attachment plugs caps. Article 408 covers switchboards and panel boards. Article 410 covers luminaires, lighting fixtures, and lamps. Article 411 covers lighting systems operating at 30 volts or less. Article 422 covers appliances. Article 424 covers fixed electric space heating equipment. Article 426 covers fixed outdoor electric de-icing and snow melting equipment. Article 427 covers fixed electric heating equipment for pipelines and vessels. Article 430 covers motors, motor circuits, and controllers. Article 440 covers air conditioning and refrigerating equipment. Article 445 covers generators. Article 450 covers transformers and transformer vaults. Article 455 covers phase converters. Article 460 covers capacitors. Article 470 covers resistors and reactors. Article 480 covers storage batteries. Article 490 covers equipment over 600 volts, nominal. Article 500 covers hazardous classified locations. Article 501 covers Class I, Divisions 1 and 2 locations. Article 502 covers Class Roman II, Divisions 1 and 2 locations. Article 503 covers Class Roman III, Divisions 1 and 2 locations. Article 504 covers intrinsically safe systems. Article 505 covers Zone 0, Zone 1 and Zone 2 locations. Article 506 covers Zone 20, Zone 21 and Zone 22 locations. Article 510 covers hazardous classified locations specific. Article 511 covers commercial garages, repair and storage. Article 513 covers aircraft hangars. Article 514 covers gasoline dispensing and service stations. Article 515 covers bulk storage plants. Article 516 covers finishing processes. Article 517 covers healthcare facilities. Article 518 covers places of assembly. Article 520 covers theaters, audience areas of motion picture and television studios, and similar locations. Article 522 covers control systems for permanently installed amusement rides and amusement attractions. Article 525 covers carnivals, circuses, fairs, and similar events. Article 530 covers motion picture and television studios and similar locations. Article 540 covers motion picture projection rooms. Article 545 covers manufactured buildings. Article 547 covers agricultural buildings. Article 550 covers mobile homes, manufactured homes, and mobile home parks. Article 551 covers recreational vehicles and recreational vehicle parks. Article 552 covers park trailers. Article 553 covers floating buildings. Article 555 covers marinas and boatyards. Article 590 covers temporary installations. Article 600 covers electric signs and outline lighting. Article 604 covers manufactured wiring systems. Article 605 covers office furnishings. Article 610 covers cranes and hoists. Article 620 covers elevators, dumbwaiters, escalators, moving walks, wheelchair lifts, and stairway chair lifts. Article 625 covers electric vehicle charging system. Article 626 covers inter-system bonding terminations. Article 630 covers electric welders. Article 640 covers audio signal processing, amplification, and reproduction equipment. Article 645 covers information technology equipment. Article 646 covers prefabricated buildings and structures. Article 647 covers sensitive electronic equipment. Article 650 covers pipe organs. Article 660 covers X-ray equipment. Article 665 covers induction and dielectric heating equipment. Article 668 covers electrolytic cells. Article 669 covers electroplating. Article 670 covers industrial machinery. Article 675 covers electrically driven or controlled irrigation machines. Article 680 covers swimming pools, fountains, and similar installations. Article 682 covers natural and artificially made bodies of water. Article 685 covers integrated electrical systems. Article 690 covers solar photovoltaic PV systems. Article 691 covers large-scale photovoltaic PV electric power production facility. Article 692 covers fuel cell systems. Article 694 covers wind electric systems. Article 695 covers fire pumps. Article 700 covers emergency systems. Article 701 covers legally required standby systems. Article 702 covers optional standby systems. Article 705 covers interconnected electric power production sources. Article 708 covers critical operations power systems COPS. Article 710 covers standalone systems. Article 720 covers circuits and equipment operating at less than 50 volts. Article 725 covers Class 1, Class 2, and Class 3 remote control signaling and power limited circuits. Article 727 covers instrumentation tray cable type ITC. Article 760 covers fire alarm systems. Article 770 covers optical fiber cables and raceways. Article 800 covers communications circuits. Article 805 covers communications systems. Article 810 covers radio and television equipment. Article 820 covers community antenna television and radio distribution CATV systems. Article 830 covers network-powered broadband communications systems. Article 840 covers premises-powered broadband communications systems. Article 900 covers tables and examples. Table 310.15. B16 provides ampacity ratings for various types of conductors based on their size and insulation type. The ampacity of a conductor is the maximum amount of current that it can safely carry without overheating. The ampacity of a conductor is affected by several factors, including its size, insulation type, ambient temperature, and the number of conductors bundled together. It is important to select the appropriate conductor size for a particular circuit to ensure that it can safely carry the expected current. Overloading a conductor can cause it to overheat, which can lead to insulation damage, electrical fires, and equipment failure. When installing electrical wiring, it is important to follow all applicable codes and regulations. This will help to ensure that the installation is safe and reliable. It is always best to consult with a qualified electrician if you have any questions about electrical wiring. Remember that electrical work can be dangerous, and it is important to take precautions to protect yourself from electric shock and other electrical hazards. If you are not comfortable working with electricity, hire a qualified electrician. In Arizona, electrical installations must comply with the Arizona Revised Statutes and the rules and regulations adopted by the Arizona Registrar of Contractors. These regulations are based on the National Electrical Code, with some state-specific amendments. Always check with local authorities for the most up-to-date requirements.